And
so it can be differently put. So let's give an example. For example, you have a sprint. So how many items can I fit in a sprint?
Yes.
But on the other way around, you have a feature, an epic with a number of items in it, and you want to know when this will be done. So those will be the different use cases.
Exactly. And I think for the sake of the example, the easier question to demo is how many items will we get done in the next, let's say, 5 days? And just then we don't have to do that much math with 5 days. So what we normally do, this is the input, like this is this throughput run chart. If you use 3 months, 2 years, it would just be longer, but that wouldn't fit our screen size. So we took 30 days here. And what you do, we want to simulate how much do we get done in 5 days. So we need 5 times a random number between 1 and 30 because we have 30 items in our input. So give me a random number, Maria, if you don't mind.
25.
It's somewhere here and it's 0. So today we got 0 items done. Bad luck. Now we roll 24, for example, and we hit the day where we got 2 items closed. So on day 2, we closed 2 items. So we can take a note of this. So we have first day 0, second day 2, third day, maybe we roll a dice and it says 1. So again, 0 items done. So not a good day. So we need 2 more. Let's say 14. That's about here. So we say it's 4 items. That was a good day. Good roll, Maria. I hire you for rolling the dice. So we have 0, 2, 0, 4, and the last roll will be a 30, where we closed 1 item as well. So now we simulated 5 days by rolling kind of individually 5 numbers and then looked up in our throughput how many items did we close. And we had 0, 2, 0, 4, and 1, which gives us a total of 7 items. So Maria, will you be happy if I tell you you will close 7 items in the next 5 days?
I wouldn't be unhappy. It's
but
more than 1 per day. So imagine, it's like if you want to know until the end of the week how many items we can close, if you tell me 7, that's super unhappy.
But you remember our definition of a probabilistic forecast. It has a probability and a range. So I can give you a range. We will close at least 7 items in 5 days, but I cannot give you a probability yet.
Exactly.
Because we ran 1 simulation now for 5 days. So what we're doing is we're doing this a second time. I mean, we don't have to do it now again with the dice rolling, but then you can imagine you maybe get the higher number or a lower number. If you're really unlucky, you hit zeros always, and then you will have a simulation that says you will get 0 items done in those 5 days. And the cool thing about computers is they're very fast at doing this, and you can run 10,000 simulations, and that's usually the number which you want to have to get meaningful results. And then you have 10,000 results for, like, you can imagine, like, you have 10,000 parallel universes, and you have the same team doing the same thing 10,000 times, and then you have different results. And then you can see, in 50%, in 5,000 of our universes, we closed 3 items or more, for example, in those 5 days. And that's kind of how you then get this probability out.